Hello everyone. Today we are gonna look into Newton's equation of motion, and we are gonna look into it using calculus. Newton equations of motion is a part of Newtonian mechanics. So the very basic objective of Newton equation of motion is to predict the future or the past given the present is known. Now, this statement looks a little philosophical, but what it basically means that if you have a stone in your hand and you throw that stone, using these equations, you can find out where the stone is gonna land, what's the net distance it is gonna cover, what is the time it will take. Uh, so, going forward, for simplicity, we are gonna consider a frame of reference x, y, and z. This is minus x. For simplicity, I'm considering only one dimension. We'll consider a particle at this origin 0, 0, 0, and then we'll say that the particle will move in this direction, in the positive x direction, and then again it will move back to the origin, and then it will go back in negative x direction, and then again come back to the origin and stop. Now, if I make a distance versus time graph of this particle, it will look something like this. That if this is the x distance, this is the time, then the particle has moved, then it will went in the reverse direction, then it went in the negative direction, and then again came back here. So this is the xt curve of such a particle. Now there are certain concepts in Newtonian mechanics which we'll go through before I derive the Newton's equation of motion. First is called the distance. So the distance is the net perimeter of this graph, of this curve. Like if you put a rope over this and you measure the length of that rope, that is called the distance, that is perimeter. On the other hand, there is another concept called displacement, which deals with only the initial and the final position of this graph. So if the particle start at x0, went this point here and again came back to this line, that means the net distance is 0, net displacement is 0. There is other concept called speed, that is distance divided by time. Another concept is called velocity, which is the rate of change of displacement. So if I want to find out the velocity between this point and this point, consider that this point is x2, this point is x3, this time is t3, and this time is t2, and this time is t3, then the velocity would be between any two given point is x3 minus x2 divided by t3 minus t2, or delta x by delta t. I'll go into more detail of velocity later on. We'll cover one more concept which is called acceleration. That is the rate of change of velocity. This is denoted by v, this is denoted by a. So if at this point the velocity is v2, if at this point the velocity is v3, then the acceleration will be v3 minus v2 divided by t3 minus t2, or delta v by delta t. So from these equations you can very clearly find out that in order to predict the velocity or the acceleration of a particle, you need at least 2 points. And this is where Newton ponders about a problem, that is it possible to find out the velocity of a particle which is moving in, let us say in our case, in only one single dimension at one given point. And this was the problem which leads Newton to invent calculus. So let's have a look on this. Consider this is x3 and you want to find out the velocity at this point, and you just know that there is some curve on which the particle has moved. So how you can find out is that you will consider a very small distance ahead of that, and let us say this is t3 dash, and we will assume that this extra distance which it has moved, so if this point, this extra distance which has moved is x3 dash, then the velocity at this point can be x3 minus x3 dash divided by t3 minus t3 dash. Now you can say that the closer on this axis, on time axis, will go, the more accurate velocity will get at x3 point. So we can write velocity as delta x by delta t, provided delta t tends to 0. What I mean to say that if the difference between the time is very, very, very small, it is not 0 but tends to 0, then we will be able to get the velocity at point x3 pretty accurately. And this term is basically what is known as delta x by delta t. And similarly for acceleration as well, if we put limit delta t is equal to 0 for delta v by delta t, this term can be written as delta v by delta t. This term is delta v by delta t and this term is delta x by delta t. Now let us consider this equation. V is equals to dx by dt. We can write this equation as dx is equals to v dt, and we can write this equation as dv is equals to a dt. Now if we integrate this equation from initial velocity u to final velocity v, and this point from t0 or 0 time to time t, considering this is at origin, then what we will get is v, limits of final velocity v to initial velocity u to a, and this will become t minus 0. This will become v minus u is equals to at, and v is equals to u plus at. This is Newton's first equation of motion. Now let's consider this equation, which was initially dx by dt is equals to v. If I put the value of v here, I'll get u plus at from equation 1, and if I move dt this side, this equation can be written like this. Now if I integrate this equation, what I'll get, this is from 0 to some distance s, and this is from 0 to some time t. I'll get x from 0 to s, and I'll get integration of 0 to t u dt plus a t dt from 0 to t. This will give me ut plus half a t square. Please consider that the acceleration here is constant. We are talking only of constant acceleration, and this term will become s. So this equation is the second equation of motion. Now if we take this equation, dx by dt is equals to v, and other equation as dv by dt is equals to a, and divide this equation and this equation with each other, we will get dx by dv is equals to v by a, which can further be written as v dv is equals to a dx. Now if I integrate it from initial velocity u to v, and here from 0 to some distance s, what I'll get is v square minus u square is equals to a s whole by 2. So I can write this as v square minus u square is equals to 2as, and this is the third equation of motion. So 1, 2 and 3, these are the three equations of motion given by Newton, and that is how we can derive it using calculus. Thanks.